What is the biggest, most massive star ever found? It's a question that actually has two answers. There are two ways we can measure a star, by volume or by mass. There are huge, supergiant stars that are 1,000,000 times the size of our Sun, but there are also stars that are 50 times more massive than these huge supergiants, but take up less space. One star has more volume, and one has more mass. A star that is massive contains more hydrogen, which in turn creates more gravity. The more gravity, the greater the force pushing everything inside the star towards the center, which is why it has a smaller volume. The largest star ever found by volume is Stephenson 218, and the largest star by mass is R136A1. Let's compare Stephenson 218 and R136 to better understand their place in the universe. Stephenson 218 is a red supergiant located in the Stevenson 2 star cluster that's almost 20,000 light-years from Earth. It can be described simply as gargantuan, with a diameter of over 1.85 billion miles, roughly 2,150 times larger than our Sun. Its incredible size makes it the largest star ever found, although its mass is significantly lower than other stars of similar grandeur. In contrast, R136 is the most massive star ever discovered and is located in the Tarantula Nebula about 163,000 light-years from Earth. It has an estimated mass of up to 260 times that of our Sun and is much brighter than Stephenson 218. Stars like R136 are characterized by their extremely high temperatures, luminosities, and intense stellar winds, and are often in the final stages of their life cycle. There are two obvious differences between these two supergiant stars: their size and their color. Stephenson 218 is a red supergiant and holds the record as the largest star by volume in the known universe. With a diameter that is over 2,000 times greater than our Sun, it is truly a colossal giant. To put this in perspective, if Stephenson 218 were placed at the center of our solar system, its outer layers would extend past Saturn, possibly even reaching the orbit of Uranus. Despite its enormous size, Stephenson 218 has a relatively modest mass for such a large star, estimated to be around 30 to 40 times the mass of the Sun. This disparity between size and mass is typical for red supergiant stars which have diffused outer layers. These layers make the star look larger, but do not contribute to its overall mass. R136, on the other hand, is a blue supergiant and is much more compact. Though far smaller in diameter than Stephenson 218, it is incredibly dense. Its diameter is about 30 times that of the Sun, but its mass is about 260 times, making it the most massive star ever discovered. The sheer density of R136 contributes to its incredible gravitational pull and intense nuclear fusion in its core. It belongs to the Wolf-Rayet class of stars, which are extremely hot and massive, but because of its mass, it has an incredibly high energy output, along with a greatly shortened lifespan. Massive stars burn through their nuclear fuel much faster than smaller stars, meaning that R136 will end its life relatively soon. Because of its enormous mass, it will most likely become a hypernova or directly collapse into a black hole. In contrast, Stephenson 218, while still significantly more massive than our Sun, pales in comparison to R136 in terms of mass. Red supergiants like Stephenson 218 typically have masses between 10 and 50 times that of our Sun, with their outer layers spread across a vast volume of space. These stars also have lower surface gravity due to their diffuse outer layers, contributing to their enormous size, but have a much lower density when compared to more massive compact stars like R136. The surface temperatures of these two stars are also dramatically different. R136 has a surface temperature of around 53,000 degrees Celsius, or about 95,000 degrees Fahrenheit. This extreme temperature results in R136 being one of the most luminous stars in the universe, with a luminosity that is about 8.7 million times that of our Sun. Its intense brightness is due to the extreme rate of nuclear fusion occurring in its core, burning through hydrogen and helium at an incredibly fast rate. Stevenson 218 has a much lower surface temperature, estimated to be around 3,200 degrees Celsius. This cooler temperature gives it its reddish color. Despite being a red supergiant, Stephenson 218 is still very bright. It's over 400,000 times more luminous than our Sun, but is a far cry when compared to R136. Red supergiants like Stephenson 218 are not nearly as hot compared to stars like R136, with their luminosity is spread over a much larger surface area. Both Stephenson 218 and R136 are nearing the end of their life cycles, but the way their stellar lives will end are vastly different due to their mass. R136 will likely end its life in a savage supernova or hypernova explosion, a violent event that will most likely leave behind a black hole. Massive stars like R136 have short lifespans as their immense gravity burns through hydrogen fuel at an astounding rate. Its total lifespan may only be 2 to 3 million years, a very short time when compared to our Sun, which is expected to live for about 10 billion. Stephenson 218 is also in the final stages of its life and will eventually undergo a supernova explosion, shedding its outer layers and possibly leaving behind a neutron star. Red supergiants like Stephenson 218 have longer lifespans than Wolf-Rayet stars, but have short lives and will live for only about 20 million years. While Stephenson 218 and R136 are both giants of the universe, they represent two very different extremes. Together, these two stars give astrophysicists essential data for understanding the limits of stellar formation in our universe. We hope you enjoyed our trip to the biggest and most massive stars, and look forward to seeing you in our next episode.